The purpose of this video is to get you comfortable with the available tools for process management at the Linux command line interface. So what do we mean by process management? Well, so far we have been using the bash, and most of the time we just execute quick external commands like ls, for example. So the deal is that, as we discussed previously, the bash executes that external command. The external command displays the results of its execution right here in the console, and then the command terminates and the bash is again prompting you to enter the next command. So it's really fast. Execution of those commands is really fast, it's really interactive. Therefore, how we use a shell, we start something, it immediately terminates, and then we have the result and we go on to the next command. Okay. Now, what would happen if instead we used a command that lasted a little longer? So I'm going to use sleep, and by the way, sleep, if we type sleep, you can see that it's also an external command. It's an external command that you're going to most likely encounter when you start doing scripting. But for now, I just want to use it to illustrate my point. So if I type sleep and a number of seconds after it as argument, so for example, sleep 5, the only thing that this command does is pretty much it does nothing for 5 seconds. And 5 seconds later, or roughly 5 seconds later, you can see that the command terminated and I'm back in the shell. Okay? So when you have commands like that that are going to execute for a little while, you might want to execute them in what is called the background. Foreground means that when I run ls, okay, if ls was taking 5 seconds to execute, so for example when I run the sleep5 command, well, the shell would not be doing anything at all. It would be waiting for that command type to finish execution and only then allow me to interact with the shell and start another command. If this is going to last for, like 3 hours of computation, then that means that my shell window would be completely useless during all that time, and if I wanted to do things on my shell, I would have to open another shell window and work inside of it instead, okay? So those are commands that execute in the foreground. Foreground means the shell is not going to try to do anything else with you while they execute. But we have a choice to execute command in the background. How do we do so? Well, we can, first off, there will be very little point in trying to execute ls in the background because it's so fast. But when we have sleep 5, for example, or any command that's going to take a certain amount of time to complete, just adding a space at the end of the line followed by the ampersand symbol, a single ampersand symbol, means that you want to run this command here in the background. And when you run a command in the background, the shell is going to tell you, okay, you have, and here this is a job ID, okay? This is a way to refer to that command. So you have a job that is the first job in the background, so I'm numbering it 1, running in this bash window, bash session, sorry. And I'm going to tell you also that this job was assigned a process identifier equal to 8278, and it's running in the background. And so you can refer to this sleep5 command either as job number 1, and the concept of job number is really restricted to this bash environment where we are using here, this bash session. If I had another terminal with another bash interpreter running, both of these guys could have different commands that they refer to as job number 1, depending on what I ran in the background in each of them. But that second number is more of a global number that's valid on your entire Linux system. So even if I had multiple bash environment running in different terminal windows, once I run a command in the background, it's assigned a unique PID, process identifier, and that PID is a way for me to refer to that background process from anywhere in my system, any terminal window, any bash session. Okay, so the job number is proper to the bash session where you started the job. The PID number is global on your Linux system. So this thing has been running for 5 seconds in the background, and I've been talking and nothing happened. But if I hit enter, the next time I try to interact with the shell is going to tell me, oh, by the way, the job number 1 is done. It completed while you were not doing anything with me, and that job was sleep 5. So if I do something like sleep, let's say 15, okay, I keep hitting enter, nothing happened. Okay, I do overthink, ls, nothing happened. But at some point, and I'm going to keep doing that until something shows up, okay? At some point, the shell, at the end of my last interaction with it, so after I typed ls, etc., there we go. At the end of my last interaction with it, which was just to hit enter here, it's going to tell me, oh, and by the way, I just noticed that sleep 15 completed. So it tells me when the background process is done executing. So executing things in the background is convenient because that means that it frees you to interact with the shell while those things are going on in the background. So typical use case, you want to use an editor, you want to edit a file named something.txt. If I run it like this, there we go, my gedit window open. I can use my gedit editor, but I cannot use anything here in my shell. The shell is waiting for that command to stop, pretty much, to complete. Okay, so when I finally close this and I say, okay, I'm done, then the shell has control again and can ask me for the next command. So typically when you have to start tools like that are going to be interactive, that have a graphical user interface or stuff of that nature, right? You want definitely to start them in the background, and this is how it's going to look, right? So you have your little editor working in the background here. Meanwhile, you can interact with the shell. You can do everything we have been doing, so far with the shell, and then you can switch back here, and you can still do things here, go back here, do things here, etc. Okay, so this is working in the background. So this is a typical example of when you would use, that ability to launch programs in the background. Let us go backward a little bit. Let's go back to the foreground execution of something like gedit. So let's say I run gedit in the foreground. So I made a mistake, right? I want to stop gedit. So in the shell here, the shell is entirely focused on gedit, waiting for it to complete. I have a few shortcuts that are really, really handy. So if I type Control-C, there we go. Control-C actually stops the execution of the program that is running currently in the foreground inside my shell, okay? You're going to learn more about that if you take an operating system class, which I really highly recommend. It's a great way to learn actually how things are working under the hood, and it's really useful for anyone in computer science, information technology, no matter what your computing discipline is. But the bottom line is that if you take such a class, you're going to learn about signals, which is a way to communicate between process on an operating system. And Control-C is just telling the shell actually send a signal to that program that is executing in the foreground and let it know that it needs to stop now. Okay, so that's why Control-C allows us to stop execution of a piece of code that is running in the foreground, okay, a program. We have other possibilities, like if I start another gedit in the foreground, there we go, all right. I can actually use another shortcut, which is also meant to tell the bash shell to send a signal to the process running in the foreground. This time I'm using Control-Z. And you see the outcome is different. Control-C resulted in the command that was running in the foreground to stop completely. Control-Z, actually I should not have used the term stop, it's going to be confusing, so let me rephrase. It led it to terminate completely. And now if I use Control-Z, now it is stopped. What is the difference between stopped and terminated? Well, terminated, that's it. The program was gone, gedit was nowhere to be found. If I ask the shell to stop it, I get back my prompt from the shell, but gedit is still here. Is it still running? Nope. If I try to type, you have to trust me because you cannot see my keyboard, but I'm trying to type here in my editor and nothing is happening because the process running my editor gedit on that file named something.txt is pretty much frozen. So if you want to think about it like that, with that vocabulary, a stop process means that the process is frozen. Okay? All right, so it's nice. We can freeze a process, we can destroy a process with Control-C, terminate it, we can freeze it with Control-Z. But now what do we do? Because we have our shell is available, okay, but we have this editor that is frozen in the background. Okay, so no panic. We have actually a few commands that allow us to manipulate processes and jobs. So I mentioned already, that we have two ways to refer to a program executing on our system. It's either by its process identifier, that number, or by its job ID. Okay, and the job ID is specific to a session in the shell. So let's start with that. If I type the command jobs, it lists all of the jobs that I started from this bash session. So in this case, I have only one that is currently stopped. So it tells me the status of the job, and it reminds me what was the command line I used to start the job. So if I was doing something like sleep, let's say sleep for 30 seconds, go in the background, okay, and I type jobs again. So first you notice that when I execute this command in the background, the shell tells me, hey, this is a job with ID 2, and this is the PID of the process. And then when I type jobs, it tells me, okay, your first job is stopped, so that's the gedit. Your second job is running right now. It's sleep 30 seconds, okay? And it's still running right now. So if I do FG, foreground, %2, okay, that's just my way to say, I want to take that job that is running in the background, okay, and I want to put it back in the foreground. So that means that during that time you saw that the shell displayed, okay, I'm putting sleep 30, the command that you typed, in the foreground. Okay, that's what FG means, foreground. And it didn't allow me to type anything for a little while. Well, that was the time necessary for that sleep 30 to complete execution. And then when the sleep 30 was completed, so the job running in foreground was completed, I get back my prompt for the shell. Okay, so FG is a command that allows me to look at a list of jobs, and I see some of them are running in the background or are stopped, and I can pull them to the foreground. So I could do the same with FG %1. So the percent just means I'm going to give you a job number. So that number here. So I pulled, the sleep 30 that was running in the background to run in the foreground, but I can also pull the job number 1, which is gedit something.txt, that is actually currently stopped in the background. And if I pull it to the foreground, that's going to resume its execution. So if I go to my gedit window now, so everything I was trying to type sooner was kind of buffered, saved in the keyboard buffer, and suddenly that process woke up and got all of that stuff. But more importantly, you can see that now I can interact. This process is actually running. It's being executed. Okay, it was stopped, it was frozen, but now because I put it back in the foreground, it's executing. And guess what? If I go here and I do Control Z again, okay, well, it's back stopped, and I can do again for FG %1 to resume it, and I can go back here and hello world, it's resumed, it's again working. Okay, so I can juggle with things like that, and once I'm done and fed up with this, I can do a Control C here, and I just kill the process, so it's no longer anywhere on my desktop to be found. Okay, so that's the basic manipulation of, and we covered only jobs right now. Okay, so in the next videos we are going to go and talk about process identifier, but right now it's a very minimal amount of stuff you need to be able to do to launch application, make sure they work in the background, and if you make the mistake to run it in the foreground, then you can Control Z it to stop it, to freeze it, then resume it, executing in the foreground if you need. The only thing we didn't cover so far is, what if I start something in, for example, the foreground? So I'm looking through my history here with the upper row. There we go, perfect. Gedit something. So I start something in the foreground. Okay, here it is. So it's running. All right. And now I want to freeze it. So Control Z. So it's no longer, blocking my shell. I can do over command, but it's not even working. It's neither working here. I cannot do anything. I cannot interact. It's frozen. So in addition to the FG command, I have another command that's named BG, background, and it works the same way. I can say put job. So first I would probably do a jobs. Okay. Let me refresh the screen. There we go, jobs. So I have one gedit stopped right now in the background. And if I do background %1, I'm going to take that frozen process that is stopped, and I'm going to tell the shell, resume its execution, but resume it in the background. So FG allows me to tell I want to to either like pull that job that's already running in the background in the foreground and let it continue execution in the foreground, or I want to pull that job that stopped in the background and resume execution in the foreground. And BG is working the same way, but it resumes execution in the background. So now I have my gedit that is still working here, okay? And that's it. All right. So BG, FG, and this person notation to specify the job number, that's going to allow you to do pretty much, well, to survive, with the command line and be able to recover if you launch something in the background and you didn't mean to, or launch something in the foreground you didn't mean to. You can move things around that way.